Hello again, everyone. Okay. Before I start, I have just one comment for the PC. Why there is no women in the stage? I feel like I'm too much on this stage. Right? Okay. So, hi again. My name is Sara. I'm going to use my second hat. I work at Packet Clearing House, and today I'm presenting like a day at PCH and how we do see the anycast DNS traffic. Just for people who doesn't know Packet Clearing House or PCH, PCH is a global intergovernmental treaty organization, a big title. We are registered in 4 countries, and we are still looking for new countries to be there. So we are providing operation support for critical infrastructure. And we do consider that DNS and IXP consider one of these critical infrastructure for the internet to work. PCH is doing that since 1994, so yeah, for more than 13 years, so that's good. What are the services that PCH is providing? As I said, we are providing global anycast DNS infrastructure for more than 300 top-level domain. And also including more than 100 CCTLD also, and IDN. Also, we are providing infrastructure for 2 DNS root server. Those are DNE. And we also work with our company or sister company, Quad9. So we also provided infrastructure for Quad9. And I'm sure that all of you now know what's Quad9. Nishal already gave you like a lightning talk about it yesterday. I keep saying anycast, anycast, anycast. So what is anycast? Maybe for some newcomers here who haven't heard about anycast technique before. If you remember when we started this network field, one of the basic fundamental we had, like each IP address need to be unique and public in the internet. And it can be 2 devices on the internet having the same IP. Anycast is a trick that breaks this fundamental a little bit. So you can have the same IP address in a multiple location online. How do you do that? As I said, it's a trick with your configuration and with your routing system. You can forward the packet to the nearest or the closest node for your customer. So if you have like a node in Joburg, for example, you prefer your Joburg users to use this node, not overseas. It's quite used now a lot by lots of services, but most common one is DNS services. So where is PCH anycast cloud, or where it's running? We are based on more than 300 locations. Basically, each these yellow dots that's present one of the nodes, or we are present. Most of these, or let's say 98% of these nodes are located in internet exchange points. Because we do think that IXPs are a neutral location where all the ISPs can connect, and then the service will be equally for all of them. So yeah, you can see that we are present in Joburg in 4 locations, or no, 6 locations. Let's see how this traffic on the DNS traffic on this network. As we all know, DNS is work as it's a UDP basically, or 53, but it can also work as a TCP. So the infrastructure or the DNS cloud that we are running is using the POS protocol, UDP and TCP, but we always get the UDP's queries are much, much higher than the TCP, as you can see in the first graph. For the protocols, the infrastructure is supporting the POS protocol, V4 and V6, but we also always get that V4 queries are much bigger than the V6. So we still need to do like more adoption for V6. The DNS query per global node and local node was pointing that global node this is PCH was considered global node is the nodes that we are having a transit connection from one of the tier 1 ISPs. So in some location, like 12 or 13 location, we get direct connection from Lumen and NTT, and those mostly in Europe, America, and some location in Asia Pacific. But we noticed that when we get these queries, most of the queries hit the global node rather than hitting the local one. So in details in another slides, you will see that most of the traffic or most of the network prefer to go to these global node or reach the one that's far away from the local node that's already located in their country or in their city. And this is one of the major outreach work we are doing. Like, we always try to reach out to networks, big networks and operators, like, fix your routing, try to use the local one. You are hurting yourself. And other thing from anycast running infrastructure, we don't want always the load to be in one node or only these 12 nodes, right? It's spread everywhere, so we need to equalize the load for this query in all the nodes around the world. The region, you can see also Asia Pacific, Europe, and Latin America. Those are the top 3, compared with LACNIC and Afrinics. Let's focus more. This was a general for lots of queries from all around the world. But if we look for .za, so this is a statistic I grabbed on 22 April. So this is like 2 days ago. We are hitting, or like we get around an average 3 million DNS query for .za. Most of them UDP, TCP are not that much. Also query IB versions, most of them version 4, but worth noting that IPv6 is quite a lot compared with lots of countries, so that's a good thing. Who are the cities that's hitting .za or that are serving ZA? Of course, everyone, like, logically, originally, Joburg should be the biggest one, or should be the one that's on the top. But no, Joburg is not. It is on the list, number 2, because Joburg is serving South Africa and serving the southern African country, and also all the .za hits that come from Africa. So all of them come to Joburg. But the top one is Hamburg, which is Germany. So that's mean lots of traffic going, as we mentioned. They are not using the local. They prefer to use one of the outside one, which is in Frankfurt. And it's also serving that part of the region, like the Europe region. Ashburn, this is number 3. This is America. So that's also one of the global nodes we are using. So that's mean lots of people, they do not, or lots of networks, they do not use their local, they prefer to use the transit, so they go to Ashburn. And worth also noting, Ashburn will serve most of the query that's coming from that region. We can see also Cape Town is in the list, but there's other sites that were serving more than the local one. When we plan to do this anycast node, we do some kind of consideration or monitoring before doing that, because we can't just go outside and put a node everywhere. This is not going to work, and from cost effective, from performance effective, it wouldn't work. So we always prefer, as we said, to host our node in IXP, where we have a neutral location where all the networks are connecting. So when we have the service, at least it will be easy for all the networks are connected in that IX to get it. We do some kind of performance measurement, so we make sure that we already do like a study before we do the deployment. Top networks from that city, where they are hitting most of the time, or where they are transiting, or where they are forwarding their packet. And then if we find like quite a lot of networks that are using our services, but from different locations, so that will be one of the target cities or one of the target locations we prefer to go there. We always work with the IXPs operators and try to help with any kind of members, meeting, engagement, and we show them statistics, more detailed statistics than what I show you here, to tell them like help fix your routing and how we can help you to use your local node rather than using the global nodes or the outside node. Also limited resources. As I said, we cannot just go outside. And running an anycast infrastructure is quite challenging. That's why we always try to equalize the performance in our all nodes. Otherwise, we don't have one node to be hit too much, and then we will lose it. So a simple task for how we do this management, we're using RIPE Atlas prop network. We have lots of Atlas props and Anchor located in a different networks. And we try to do trace routes for a valid destination. And normally when we say valid destination, we do our services, either PCH anycast services or Quad 9, because we would like to make sure that the reference we are using for this measurement is up and running, and we know the service is operating, and we know that there is a peer, or it's located in an exchange point, or it's somewhere. So it's always easier for us to use our network as a reference. We know where we are. So I did a quick measurement I was trying to do for South Africa, but I felt afraid, like I need to travel back, so let me pick another country, where AE. AE, it's quite a lot of networks are connected there, but I just give like 2 examples for 2 networks. We can see that AS60924 is connected to the exchange point. They have exchange point, UAE exchange point that's run by DECX. And PCH is already operating there. We have our service there up and running. That AS number is a good one because they are connected to the exchange point, and when we did the testing with them or performance, we found that most of the services, or all the services that are hitting for PCH, it's coming from Dubai side. But the naughty one is 3491. They are connected to the exchange point, but they do not use the service that's provided by the local node. Like, if we can see in the details, for the first AS number, as I said, if we are trying to like trace routes for any ns.pch.net, this is like the basic, or this is the main DNS services that PCH is providing. We can see that we are hitting DXP, which is Dubai side. But you can see the other one, they prefer to send their traffic to Equinix, Singapore. So imagining DNS query travel from Dubai to Singapore, that's just a query, and then the response will come back. This is only for UDP packet, which should be fast. But this is a DNS, and it will take how many? 77 milliseconds. That's quite a lot for DNS services. So this is one of the simple exercise you can do in your network, so you can test the performance for my network and where I'm hitting and where I'm reaching any services. Most of the network, when we do this research with them, we categorize the reason for 3 options. Either they don't peer in the exchange point, and that's like, why you don't peer? What is the reason? So we always try to speak to them, connect to your exchange point, use the benefit you have, use the resources you have locally. Either misconfiguration from the network, because they always prefer to send the traffic to the transit, not to localize it. And some of them, they use the wrong AS filters. So when they try to filter what they get from the exchange point or what they are sending to the exchange point, they use wrong filters. So the traffic will definitely use the transit. So Our recommendation will be always remember your peering local preference should always be higher than your transit. And please don't announce 24 and these things. No, no, no. Number two, advertising more specific will hurt you first because, as I said, if you advertise more specific, definitely your transit will be used. Whatever you are doing on other side, filter or anything, it wouldn't work. Try to use modeling tool for filtering and building your filters. AS sets are very good ones for that. Connect more Atlas probe and anchor in your network, so it will help you to do more statistics than that, because when you connect to the Atlas probe, you will be able also to do some kind of measurement from other probes that's allocated in a different network, not only you. So you will be part of a big network and you can run measurement from outside your network. So the message, I always have message by end of my slides. Every time you send a packet international to the international destination that could be served locally, you are subsidizing the internet ecosystem in that country or city or in your network. And remember all these statistics that I have just mentioned for you, this is a DNS, which is small and fast. But when you do that for data traffic, which is CDNs and things like that, you are really hurting your network and you're hurting your customers. And that's why your customer will be always complaining, this is slow, this is not working, and so on. That's all from me. Thank you for attention and hope it was useful for you guys. On time.
Hello, Graham from the internet. Anycast is cool. We like Anycast. Some people still don't run Anycast. Do you know of any reasons where not running Anycast, specifically for DNS, would be a benefit over using Anycast? I mean, it looks like Anycast is a no-brainer, but do you know of any reasons why someone would choose to not run Anycast?
Okay. As I said, Anycast network or running an Anycast, it's a little bit challenging because you need to have a quite good performance system, so you will be able to manage all your DNS nodes around the world. And for DNS services specifically, where you need to make sure that your zones and your zone data, SOA, all these things need to be on sync in all the location. So maybe I think people will feel afraid from this way to sync all these zones around the world. It's a tricky. Not all the zones will be connected in the same infrastructure. Like some nodes will be connected to maybe, as we have, for example, some nodes connected to tier 1, when we get like 10 gig ports, it will be very fast. So syncing the data very fast. Other nodes can be very slow because the bandwidth is challenging. So that's also one of the things. So I think these challenges that have maybe some CCLT or some DNS operators will think like, no, it's easier for us to have them all in one city, one location where we can manage all these things, and then will be easy to operate. Okay.
Sean from the internet.
Sean.
So recently there was a fairly large DNS issue with Darkosa. They don't run Anycast. Should they run Anycast? And if they're not running Anycast, do you know why?
I think if we have people from the ZA, that will be a good question for you. Why you don't run Anycast? What's the reason for that? I read about this on the internet. It was like in the mailing list. I found like lots of noise about it. But I don't know why they are not running the Anycast, because it's really useful and helpful when you have, for example, DNS service on one location. At least your service will be still available in the internet in another site or in another location. So even one site has been attacked or has been out of service, you can easily isolate that service temporarily in that location, but you still will have your services will be up and running in a different location. And we have this in this scenario with lots of CCTLDs where they have an issue. Our team work with them like to isolate where is the attack node and try to isolate this, as I said, disconnect this one. But the other nodes will be working fine until the TTL of your zones will be finished. And that will give you enough time for you, I think, to troubleshoot your service and see what's happening. Hi, Nishal.
Hello, my name is Nishal Govardhan. I've got my PCH hat on, so I also work at Packet Clearinghouse. I thought I'd just add a quick comment to what Sara is saying. Graham, your question about why don't people do anycast, Sara's answered it by saying complexity. That's it, it's exactly that. Everybody that we've spoken to that says they don't want to do anycast think it's unnecessarily complex. And if you think it's complex and you want to know about it, I'm next door most of the time, so you're welcome to come talk to me. It's not. It really is dog simple. The technology and the tools to do it today are much simpler than it was 21 years ago when it was first done in South Africa, right? TCP anycast needs a little bit of a mind shift change against UDP anycast, but again, it's certainly not difficult to do, and it's done at scale across the internet today. To answer the second generic question, is there a case where anycast doesn't help? No, there isn't. Because fundamentally, anycast is a load-sharing technique. That's how you want to think about it. So whatever it is that you're trying to mitigate against, whether it's a problem, whether it's denial of service attack, whether it's simply spreading load, that's what anycast does really well. And the thing is that there's nothing on the internet that we have today that does this better than anycast. If you think you have a better answer, I would love to debate you. I'm next door. Thanks.
Hi, my name is Jerry from the ZARC. To answer the question that we don't run anycast, we do. Our anycast is run, our service provider is NetNode.
Analog. Okay. Sorry. How did you
Hi, Ed from NOG. I'm in the process of playing with some anycast stuff so far, just because I got bored the other night when I couldn't sleep. It really isn't that complex. It's a bit of a schlep maybe to monitor it and automate it, but it's not complex. Just Jerry, a pass-on question, are you running one anycast server, or have you added more than one anycast? Because you currently last I checked, you only had one, and all your others were single-casted.
We've added two more. It was one before the incident, and we've added two.
With another provider?
With the same provider.
Okay, so still one node only in South Africa.
Okay. Okay. Thank you.
Thank you very much, Sarah, and thank you for the questions. Next, we have Warwick Ward Cox. He is